Now in this video we are going to take up a problem on development of lateral surfaces of solids. How to analyze this problem and solve manually. The problem reads as a square prism of base side 30 mm, axis length 60 mm is resting on HP on its base with all the vertical faces being equally inclined to VP. It is cut by an inclined plane 60 degrees to HP and perpendicular to VP and is passing through a point on the axis at a distance 50 mm from the base. Draw the development of the lower portion of the prism. So to do that, first we will go for an initial position wherein he says a square prism of base 30 mm and height is 60 mm. So the vertical base is equally inclined to VP. So here you can see when you draw by an angle of 45 degree, this rectangular face and this rectangular face both will going to have equal inclination with respect to VP. And then he says the section plane perpendicular to VP and inclined at 60 degrees to HP passing through on the axis. This is the axis wherein O dash and O1 dash, and it is 50 mm above the base. The base is here, which is the XY line. From the base it is at 50 mm and where the section plane is inclined at an angle of 60 degrees. So this is how you will begin to get this. So that means a square prism is cut by this inclined section plane. Since it is cut by an inclined section plane here, and then develop the lateral portion of the remaining portion of the prism. So this is the remaining portion which has been shown by using the dark lines. The top surface has been removed. So how to solve this problem manually? First we are going to draw the XY line and we mark VP and HP. So you take any horizontal line from here by using the protractor. You measure an angle of 45 degree on this side and also on this side and draw two angle lines of 45 degree each. Then by using the compass you measure a radius of 30 with this as center, cut an arc on this side and also cut an arc on this side. Then by using these 2 points with this as center, draw an arc of the radius 30. Similarly with this as center, cut an arc on the previously drawn arc. So you mark the points as A, B, C, D. That is the top surface, and bracket P, Q or S, which is at the bottom surface. Join A to B, B to C, C to D and D to A with a dot line. Then join between AC and DB with a diagonal lines which will be of thin lines, and you mark this as O1, and this is a square of 30 mm and show the angle of 45 degree on this side and also on this side, which will go to be having equally inclined to VP. This is what we can see, resting on HP on its base with all the vertical faces being equally inclined to VP. So which are the vertical faces? A, D, S, P, that is one vertical face, and D, C or S, which is the another vertical face which is equally inclined to VP. Now here then once you look from the front view, you can see the height of the prism. So draw a vertical projector. You measure from XY line a distance of 60 and draw a horizontal line. And draw a vertical projector from AP to the front view. Similarly from BD to the front view and also from CR to the front view till to a height of 60 mm. Then as you look from the front view, ABCD is the top surface, and which is A dash is visible, B dash is near to the observer, it is visible, C dash is also near to the observer, is visible, and D dash is away from the observer, so it is invisible. As you look from the front view, O is near to the observer, so O dash becomes in bracket. Similarly on the bottom side you will going to have P dash, Q dash, R dash and S dash in bracket and O1 dash in bracket. Now all these things you join by means of a thin lines, don't dark them. Then since it is the axis is at the center line of this is the axis. From the axis you measure from the XY line, you measure 50 mm on the axis and draw a horizontal line. When you draw a horizontal line here, what happens? A section plane which is parallel to HP and perpendicular to VP. Since it is perpendicular to VP, you are getting a line in the front view. And from that point, you measure an angle of 60 degrees with respect to the horizontal and then draw an inclined line. That is, this is the section plane which is acting. This is the representation of the section plane. Once you do that, so after that, what you need to do is, so that means you are cutting the prism onto two parts such that the section plane is at a height of 50 mm from the axis, from the base on the axis. Once you do that, now the section plane is passing through this edge here and this at the top surface. Now, so once you do that, then you darken the remaining portion of the prism on the lower portion. So A dash and P dash, visible to visible is visible. So from here only till P dash it is visible, dark. Then similarly on BQ, that is B dash, Q dash, from here to Q dash is the dark point. C dash, R dash is visible to visible is visible. So the section plane is passing between B dash and C dash. So here till here you dark this. Similarly, this section plane is not passing through the base. So you dark from P dash to R dash. Similarly, A to B, B to C, C to D and D to A with a dark line. Now here, first what I need to know is how to do the development. The development I can do only by considering whether it is in the true length or not. The development is always been made for the actual length of the line. So since A dash, B dash, C dash, D dash are parallel to HP, so AB, BC, CD, DA are in true length, which is equal to 30 mm. Similarly, P dash, Q dash, R dash, S dash and P dash all are parallel to HP. So PQ, QR, RS and SP are also in true length, wherein the size of the true length is 30 mm. Similarly, AP, BQ, CR and DS all are parallel to VP. So therefore, in the front view, you are getting the true length. So here, the true length of the longer edges will be 60 mm. So since all these sides are in true length, therefore you need not have to find the true length. In general, any prism for that matter will always have the true length. So how to develop this now? So to develop this, first I need to consider a square prism without considering the section plane. How to do that? I need to cut at any particular edge or the longer edge. So I will cut along AB. So then I will try to open A to B, then B to C, then C to D, then D to A. So that means how many faces we are going to have? You are going to have 4 faces. One face is AP BQ, second face is BQ CR, third face is CR DS, and fourth face DA PS. So now how to do that? So you can, since this line is also in the longer edges is also in true length and the shorter edges is also in true length, therefore I need not have to find the true length. So you draw a horizontal line from C dash till here, similarly from R dash, and you consider at any distance from the front view, you consider any point and then draw a vertical line. So this is the first line wherein I want to cut the prism in the longer end, that is from A dash B dash. So you mark them as capital A, capital because AB is in true length. Then after that you need to open AB. What is the side of the AB? The side of the AB is 30 mm. So from A you measure a distance of 30 mm, and similarly from B you measure the distance of 30 and mark this point as capital B and capital Q, and then draw a vertical line from B to Q. Once you do that, again after BQ you have a CR. So that is BC. What is the distance? Again it is 30. So since we have 4 sides of 30, so from BQ you measure 30 mm and draw a vertical line. Similarly from this, and you mark that point as CR. Then from C you measure 30 mm and draw one more vertical line. You mark that point as D and S. Similarly from D you measure a distance of 30 and draw one more vertical line, which is DA, which is AP. Mark them in capital letters. So since it is a square prism, how many sides will going to have for a square? You have 4. So you have 4 rectangular faces. One is AB BQ, that is AB BQ. Second one is BQ CR, BQ CR. This is one more rectangular face. And CR DS, CD RS, that is CD RS. Then DA PS. So D to A, P to S. So we have 4 rectangular faces. So this is how, this is a development of a square prism without considering the section plane. Once you consider the section plane, what happens? Let us see. Now, once you consider the section plane here, so the sectional plane is passing through some of the longer edges and also on the shorter edges. So here, how this naming should be done, the manner in which you have opened a development, accordingly you need to do it. So what does it mean? So first I am cutting along AP. Then this is the first stage in the development process or the developer sheet. So since the section plane is passing through A dash B dash, so this is the first line. So you mark that point as 1 dash. After that AP, so you have BQ, PQ, there is no, since the section plane is not passing through the none of the base edges, so PQ or S you need not have to consider. Then after AP, which is the longer edge you have, the longer edge which one you have is BQ. Is the section plane is passing through DQ? Yes. B dash, Q dash. B dash is visible point, Q dash is visible point. Therefore, you mark that point as 2 dash. So after BQ, which is the one you have BC here. After BC, you have CR. After CR, you have CD. After CD, you are going to have DS. After DS, you are going to have DA. And after that, you have AP. So this is how it will going to be considered. So after BQ, the first, next thing is BC. Is BC, is the section plane is passing through BC? Yes. You mark that point as 3 dash. After that BC, then we have, is the section plane is passing through CR? No, because the section plane is passing only here. After BC, you don't have CR, so you need not have to consider CR. After CR, you have CD, which is that C dash, D dash. C dash is visible and D dash is invisible, and the section plane is passing through that. Yes, you mark that point as 4 dash as invisible, because C dash is visible and D dash is invisible. So visible to invisible is always invisible. Therefore, 4 dash will going to become invisible. After CD, what we have? We have DS. Is the section plane is passing through DS? Yes. D dash is invisible and S dash is invisible. Invisible to invisible is invisible. So you mark that as 5 dash. After DS, you have DA. No, there is no section plane passing through DA. Leave that. And then you have AP. Is the section plane is passing through AP? Yes. So it is that 1 dash. So this is how you will be able to name the sectional points by considering the developed portion of the surface. Once you do the naming of the sectional points, then I need to transfer them to the developed point. So first one thing is A dash B dash is in true length? Yes. And AP is also in true length? Yes. So naturally, since the point is on the true length side and AP here also it is in true length, therefore you transfer it directly. How I can do that? From 1 dash, you draw a horizontal projector which crosses through both AP at the beginning and both AP in the beginning and also AP in the end. That is 1 and 1. Then is the section point is passing through B dash, Q dash? Yes. And this BQ is also in true length and this B dash, Q dash is also in true length because BQ is parallel to BP. So since it is passing through that point, so you directly project that onto BQ, you are going to get this point too. And similarly, you have a point on D dash and S dash, which is that DS, which is here. So you transfer them from this point. You just project it again till to get this point DS, wherein you mark that point as 5. Then I need to consider the next one, which is B dash C dash. Here the BC what you have is in true length, but the B dash C dash here in the front view is not in true length because BC is inclined to VP. Since BC is inclined to VP, what is the length of BC? In this case it is 30 because B dash C dash is parallel to HP, so we are getting the true length. Since BC is inclined to VP, this B dash C dash will not be in true length, but this BC is in true length. So I cannot measure the distance from B dash to 3 dash, and from B you cannot cut it. Then what I need to do? I need to find the top view of this, which will going to be in the true length because B dash C dash is parallel to HP. Therefore, BC, that is 3 dash, will be in true length. Draw a vertical projector from B dash C dash till to the BC on this. So you mark that point as 3. Then what I need to do? You measure the distance from B to C. It is around 8 mm, but in computer it is 8.16. Then by using the compass, you measure the distance from B to 3. From B, you cut an arc on this between B and C. So you mark that point as C. Once you get this point, after that you have 4 dash. Where is 4 dash? 4 dash is on CD. So here CD is in true length, but here C dash and D dash is not in true length because CD is inclined to VP. So I need to find the true length of that 4 dash. How to get the true length? This B dash C dash is parallel to HP. So this C dash D dash is parallel to HP. Therefore CD is in true length. So once you do that, so you draw a vertical projector. Since it is on CD, it is cutting on this. You mark that point as 4. Then you measure the distance from C to 4 towards D. From C, by using the compass, which is 22 mm, but in this case it is 21.884. From here, you transfer it on CD and you mark that point as 4. Once you get this point, then I need to go for D dash S dash. Here DC is also in true length, and here D dash S dash is also in true length. Then therefore you transfer it on to CD also. You mark that point as 5. So since we have completed all the sectional points which was there in the front view has been transferred into the developed portion of the square prism. Then what I need to do? Join the numbers, that is 1 to 2, 2 to 3, 3 to 4, 4 to 5 and 5 to 1. So this is what you can see here. Join between 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 1. Once you do that, the remaining portion which has to be retained, it has to be darkened. So from 1 dash to P dash is dark. So you dark between 1P and here also 1P. Then you have to dark between 2 dash to Q dash, that is B to Q. So you draw a horizontal projector from B dash Q dash, which will cut BQ here, which is 2, and then it is D dash and S dash. So you draw a horizontal projector from BQ to DS till here. So you mark that point as. So you get the mark the point as 5. Now you seems between 2 dash to Q dash is darken here. So you dark between 2 to Q, and similarly from 5 dash to S dash. So from 5 to S you darken. Then this portion is dark, that is C dash R dash. So here also you dark that CR. Then 1 to P is also dark, and since here P dash to Q dash to R dash to S dash, and S dash to P dash is entirely darkened. So from P to P you dark this point. Then this is how you will be able to write the development of a square prism, which is cut by a section plane at certain angle on the axis. So here show the dimensions of PQ, which is 30, and from P to P, which will be into 30 into 4, which becomes 120. So this is how you will be able to solve the problem of development of surfaces, which can be analyzed and solve it manually by using the sketchbook. Thank you.